So round robin scheduling algorithm, this is the CPU process scheduling algorithm. And in this algorithm, each process is assigned a fixed time slot in a cyclic way. Then it is simple and it is easy to implement, and also it is starvation free as all the processes get fair chance to share the time of the CPU. And this is one of the most commonly used process scheduling technique. It uses the preemptive approach because your processes are assigned a CPU only for a fixed time slot. And the main disadvantage of this process scheduling algorithm is that it results more overhead because of the context switching. Context switching means here your operating system, it switches the process from the ready queue into the run state and from run state into the ready queue, which is called as context switching. Here process identification number, arrival time of that process and burst time, that is total execution time required to complete that process, is given. So process identification numbers that are assigned by an operating system to identify that process. And arrival time, it is indicating the time at which the process is arrived in the ready queue. So here the criteria used by the round robin scheduling algorithm is the time quantum. That is, time quantum is assigned by an operating system to each process. So here it is given that time quantum assigned by an operating system is 2 time units for each process. And here this algorithm, it uses the preemptive approach. So again, for each algorithm, the process of drawing the Gantt chart is very important, because from the Gantt chart only we can find out all the times which are asked in the problem. So here the arrival time and burst time is given. So same process we will apply. So at the starting of the problem, at first we will check whether any process is arrived at 0 time unit in the ready queue. So the given table, it is representing the process table in which we are representing the arrival time and the burst time. So here only 4 processes are there. So from these 4 processes, you have to check that which process is arrived at 0 time unit in the ready queue. Okay. So process P1 is arrived at 0 time unit in the ready queue. So what we will do here, we will shift this process P1 from this process table into the ready queue. So now on the right hand side, I am representing the ready queue. Okay. So see, on the right hand side, I am representing the ready queue. What I will do here, I will shift the process P1 from this process table into the ready queue. So only one process is there in the ready queue. At 0 time units, only one process is arrived. So what we will do here, so here we will represent the Gantt chart now. So process P1, it starts at 0 time unit. Only 2 time units are assigned by an operating system to the process P1. So this process P1, it will execute only for 2 time units. Okay. So you have to represent that 2 time units on the right hand side of this process, of this rectangle. So on the left hand side, we are representing the arrival time, and on the right hand side we are representing the completion time of that process. So here process P1, it is not completed because the total processing time or burst time required for that process, it is equal to 5. But as operating system, it is executing its job only for 2 time units. So once the 2 time unit of that process will get completed, that process, it will preempted from the, it will get preempted from the run state or from the CPU, and it will get added back into the ready queue. But now before adding that process P1 back into the ready queue, at first what you have to check. So here you can observe that process, when the process P1, it was executing. So when it was executing, that time you have to check whether any process is arrived in the ready queue or not. So here you can observe that when the process P1 was executing, the process P2, it was arrived at 1 time unit. And when the process P1 was executing, that time at 2 time unit, the process P3, it was arrived in the ready queue. Okay, P2 and P3. So two processes are arrived in the ready queue when the process P1, it was performing its task or when it was doing its job. So what you have to do here, now here you have to shift the process P2 and P3 from the process table into the ready queue. Okay. So what we will do here, see, this is your ready queue. I have written the process P1 first. Then process P2, it is added at the end of the ready queue. Because at 1 o'clock, this process P1, it is arrived at 0 o'clock. The process P2, it is arrived at 1 o'clock. And process P3, it is arrived at 2 o'clock. Because that time the process P1 was executing. So what you have to do here, add the process P3 in the ready queue. Okay. So the process P2 and P3, it was added in the ready queue when the process P1 it was performing its job. Now, as we are using the round robin scheduling algorithm, only two time units are assigned by an operating system to each process. This process P1 it will get preempted from the run state, or it will get preempted from the CPU. And now here total amount of time required to finish its job is equal to 5. अभी 5 में से 2 टाइम यूनिट का एग्जीक्यूशन उसने कंप्लीट कर लिया है. So how much time is required for process P1 to complete its job? 3. So what we will do here, so in this table I will cut this number 5 now. Okay, because it has completed 2 time units, so I will cut that 5. See how I am representing it in the table. So I have cut that 5, and on the right hand side of this 5 I will represent the remaining amount of time which is required for the process P1 to complete its job. Okay, so process P1 यहाँ से cut हुआ है, and that is added at the end of the queue because it has not finished its job. So that's why it is added at the end of the queue. Okay. Now here at the start of the queue, process P2 is there. Okay. Process P2 is there. Then in the Gantt chart means now your process scheduler, it will shift the process P2 from the ready queue into the run state, or it will assign the CPU to the process P2. So what we will do here in the Gantt chart, we will represent the process P2. So total time units required to complete the job of the process P2 is 4 time units. Completion time of this process P2, it is 4. Before preempting that process, what you have to check here. So when the process P2 was executing, that time you have to check whether any process is arrived in the ready queue. This is the sequence that how to execute the processes by using the round robin scheduling. So here you have to check when the process P2 was executing, which process was arrived in the ready queue. Yes. So all of you are right, means when the process P2 was executing, process P4, it is arrived at 4 o'clock. That is at 4 time unit. So what you have to do, you have to shift this process P4 from the process table and add it into the ready queue. So you have to add this process P4 at the end of the queue, that is after the process P1. Okay. So now here what I will do, I will add this process P4 after the process P1 because it is arrived at 4 o'clock. So I have added this process P4 at the end of the queue. So what you have to do in the ready queue, you have to cut this process P2 like this, and then you have to add that process P2 at the end of the ready queue, that is after the process P4, because its job is not completed. So that is added at the end of the ready queue. Okay. So here you can observe that all the 4 processes which are given in the process table, all are entered into the ready queue. So now you have to continue this sequence until all the process will finish its execution. Now see the next process which is present in the ready queue. So the next process which is present in the ready queue is process P3. So now you have to shift this process P3 from ready queue into the run state. That is, we have to assign the processor to the process P3. So what I will do here, I will assign the processor to the process P3. Ending completion time for that, yes, it is 6. So only 2 time units are assigned to the process P3. So what you have to do here, So here all the processes are added in the ready queue. So there is no need to check whether any process is arrived at 6 time unit or when the process P3 was executing, because all the processes are added in the ready queue. So what you have to do now? Now you have to check the remaining burst time for the process P3. But so I will cut that 2 and here I will write 0. That is that process P3, it has finished its execution. Okay. Then what you have to do? You have to cut this process P3 from the ready queue and it has finished its job. So there is no need to add that process P3 at the end of the ready queue. So this process P3, we have to cut that process P3 and it is completed. So it will enter into the terminate state or into the end state. Okay. So only three processes are there which are standing in a queue. That is P1, P4 and P2. So what you have to do now? Now process P1, it is holding or 3 time units are required to complete the job for the process P1. So again the CPU, it is assigned to the process P1. The completion time for this process P1, it is 2. So 6 plus 2, which is equal to 8. So still the job of the process P1 is not completed. You have to cut this number 3 and you have to represent the remaining number. So P1 यहाँ से आपको cut करना है and it is added at the end of the queue. Okay. So now we have to assign the processor to the process P4. The completion time for the process P4? Yes, it is 9. So though the 2 time units are assigned by the processor operating system to each process, this process P4, it will require only 1 time unit to complete its job. So completion time will be 9. You have to cut that 1 and write down 0. That process P4 has completed its job. Then you have to cut that P4 from the ready queue and it has completed its job. So no need to add that process P4 at the end of the queue. Yes. So after that you have to assign the processor to the process P2. So process P2 अभी आपका उसको CPU assign होगा. So he is having 2 experiments with him. So professor will correct his 2 experiments. So tell me that will be completion time will be 11. Yes. So it will be 11. Then after that you have to cut that 2 from the process table, write down 0 there. Means यहाँ पे burst time सबका 0 आना चाहिए, तब तक आपको process ये repeat करना है. So you have to write down 0. After that go in the ready queue. So you have to remove this process P2 from the ready queue and then that process is terminated and then only one process is remaining in the ready queue, that is P1. So add that process P1, assign processor to that process P1. Tell me the completion time for this. So only 1 time unit is remaining for the process P1. So it is 12. So after that you have to cut that P1 from the ready queue. So no processes are there in the ready queue. Also you have to cut this 1. ये 1 यहाँ से कट करना है प्रोसेस टेबल से and write down here 0. मतलब आपको burst time, here you can see that burst time of all the processes are equal to 0 and there is no process remaining in the ready queue. So all the processes has completed its job. सब students के experiment check हो गए, means here your process is completed and this is your Gantt chart. So now from this Gantt chart now you can easily find out all the times. So completion time for the process P1 is, so from this table you have to find out the completion time. So you have to search this process P1 on the right hand side of the Gantt chart. तो सबसे यहाँ पे भी process P1 है, यहाँ पे भी process P1 है, लेकिन आपको rightmost side का process consider करना है. Completion time for the process P1 is 12. So I will write that 12 over here. Then what is the completion time for the process P2? It is 11. Yes. So it is 11 because process P2 आपका यहाँ पे complete हुआ था. Process P3 कहाँ पे complete हुआ? यहाँ पे complete हुआ है. Okay. So P3 का completion time था 6 and P4 का completion time है, it is 9 time. So turnaround time means total amount of time spent by the process in the primary memory. So you have to subtract arrival time from the completion time. That is 12, 10, 4 and 5. Yes. What is waiting time? That is the amount of time which is required for the process for getting the CPU. So it is turnaround time minus the burst time. So it is 7, 6, 2 and 4. And response time, time at which the processor is assigned to the process. So here you can see the left hand side time. तो आपको क्या करना है, यहाँ पे P1 को प्रोसेसर मिला था 0 टाइम यूनिट को एंड इट हैज अराइव्ड एट 0 टाइम यूनिट, सो 0 - 0 0. देन प्रोसेस P2 को CPU मिला था at 2 o'clock बट इट हैज अराइव्ड एट 1 टाइम यूनिट, सो इट इज 2 - 1 1. मतलब लेफ्ट हैंड साइड का टाइम देखना है आपको. प्रोसेस P3 को CPU was assigned at 4 टाइम यूनिट्स, so 4 - 2 2. And for processor P4, the CPU was assigned at 8 टाइम यूनिट्स but it has arrived in the ready queue at 4 o'clock. लेकिन उसको 8 o'clock को मिला था प्रोसेसर, so 8 - 4 4.